Hello, my name is Franke, and I'm going to present our short paper titled Compact Phase Histograms for Guided Exploration of Periodicity. Our approach aims to find periodic reoccurrence of events in temporal data. In particular, our approach considers cases where the period length of the periodic behavior is not known beforehand. Periodic behavior here can also be interesting to analyze in the context of other data attributes, such as geographical space. Various methods for analyzing periodic behavior in time series exist already. Fourier analysis works well for sampled time series, where the signal is sinusoidal. For event data, however, the sampling can be expensive, and the very blocky signal usually produces a lot of false positives. Seasonal trend decomposition and dynamic mode decomposition can work well to extract a clear signal from a time series. However, they require prior knowledge of the period length and are too expensive to compute to try them out on thousands of possible period lengths. Our approach tries to do exactly that by calculating a cheap-to-compute rough aggregation for thousands of possible period lengths. In addition, we calculate quality measures to guide to interesting period lengths. Previous works have explored aggregated visualizations to detect periodicity. In the representation on the left, each period is mapped to one row. Periodic behavior is then visible by vertical patterns. Some of these works use a calendar layout here so that each row is a week. Of course, the same principle can also be applied to a spiral layout. Both variants work well to find periodicities and can even be used interactively, changing the period length to find interesting patterns. However, they do not scale very well to longer time intervals as they take up more and more screen space. Our approach works on event data. These are first aggregated into bins. By stacking these bins period by period on top of each other, we would get the Cartesian representation from the previous slide. However, we aggregate once more here, vertically. If the vertical patterns in the Cartesian representation line up, they also show up in the aggregated phase histogram. This entire computation is very cheap, so we can repeat it for thousands of possible period lengths. To guide users to interesting period lengths, we compute two quality measures. One is the von Mises vector strength, which can be visually interpreted as the barycenter of the phase histogram, if its start and end were connected. Here, high values towards 1 indicate a non-uniform distribution. However, because the barycenter is used, symmetric non-uniform distributions like those in the last two rows are not properly recognized. Such distributions happen, for example, if we look at integer multiple period lengths of that of the signal. The second quality measure is the entropy estimation of the histogram. Here, a low value indicates an interesting distribution. Entropy estimation handles symmetry better, but the values quickly rise even with little noise. By offering both measures, we can reduce the individual drawbacks. Our visualization is centered around a widget. Here, each row of the pixel matrix visualization represents the phase histogram for one period length. The currently selected row is indicated, and users can scroll up and down to change the period length. The phase histogram for the current row is also visualized as a bar chart. On the right side, a vertical histogram indicates the calculated quality measure for each row, so we can quickly see interesting rows. Besides the widget, users can select a different period length quickly from the timeline. Here, suggestions based on the quality measures are also shown. To find relationships between periodic behavior and other data attributes, we also map phase to color or shape in other views. Here we have geographical data of high tide events at the US coasts. With the selected period length of 1 year, we can see periodic behavior in the phase histogram. We can also see from the different color or shape of the map markers on the east and west coast that the high tide events usually happen at different times in the year at the two coasts. Our prototype is highly interactive. Here we scroll through the widget, slowly increasing the period length until we find an interesting pattern. We can take a closer look at the data in the Cartesian layout. We then change the period length quickly, following a suggestion of the prototype. Based on the Cartesian layout, we can see that the events only occur in every second period, so the periodicity of the event is probably twice the current selected period length. In conclusion, our approach offers a first, heavily aggregated overview in which periodically recurring events can be seen. We offer guidance to potentially interesting period lengths and map phase to color or shape in other views to find relationships between periodicity and other data attributes. We see our approach as a first step in a larger analysis where other methods, such as seasonal trend decomposition, can be applied on demand for interesting looking period lengths. The compact widget is also meant to be integrated into a larger visual analysis interface to that end. You can find our source code on GitHub. Thank you for listening.